All right, I'm going to do an example from a different perspective, but first I want to define something. Eccentricity is defined as the value c over a, so the distance from the center to the focus to the center to one of the endpoints of the major axis. That's something that may come up because a lot of the questions that you'll get in homework and on quizzes and tests is they're just going to tell you some different things and then they want you to come up with the equation. For example, if I told you the major axis endpoints are at -2, -1, and 8, -1, and the major axis has a length of 8. Well, the things that I would hope you'd pull out of this is, first of all, the center. We always need to know where the center is. The center is always going to be between the different endpoints of the major axis. So I know, without a doubt, between -1 and -1 is -1. The midpoint of -2 and 8, I would just add them, so 8 plus -2 and then divide it by 2, and I would say that that's equal to 3. So that's awesome because right away I can say x minus 3 squared y plus 1 squared equals 1. Equals 1. Now all I need to do is figure out what a and b are, and is this ellipse going to be wider or is it going to be taller? Well, the first clue to that is that the major endpoints change my x coordinates, so I can conclude right away that it's going to look like that. So I'm going to have an a squared here and a b squared there. Hopefully you've been thinking, hey, I know what a and b are, or I could find them quite easily. If I went from 3, -1 to 8, -1, that's a distance. Again, the -1s don't change, but from 3 to 8 is a distance of 5. So a is going to equal 5. So I can make this 25. And if the minor axis length is 8, remember that's 2b. So I can just divide it by 2 and say that b is equal to 4. So I'll plug that in and bam, just like that, we're finished.